Hello everyone. In this video we are going to continue our discussion and we will focus on community ecology. So a community is a group of populations of different species living in an area, and as we said before, the definition of an area is not well defined, so it's up to everyone who is studying a community to define what are the boundaries of their area. And as you can see, while we study different populations, the main aim is to focus on the different interactions that are occurring between these populations. So different arrays of interaction is the aim of community ecology, and that's why in the coming few slides we are going to deal with different types of interactions. These interactions are taking place between members of different species in the community. That's why we call them inter-specific interactions, and it could be competition, predation, herbivory, and symbiosis, which is actually can be subdivided into parasitism, mutualism, and commensalism. And these effects can be summarized by the mathematical signs like positive, when there is a positive interaction. So one species is positively affecting the survival and reproduction of the other organism, or a negative, when it is negatively affecting the survival or the fitness of the other organism, or zero, when there is no effect or a negligible effect is there. So we covered these interactions in previous videos. That's why I'm going to go through them quickly to revise them. Starting with the first one, we have competition. So we call this inter-specific competition in order to highlight the fact that we are talking now about competition between members of different species. And this to differentiate it from what we have discussed before when we discussed intra-specific competition, so competition between members of the same species, for example, between bacterial cells growing in a test tube. So this intra-specific competition is going to decrease the growth rate, the Rmax, and this is going to decrease the exponential phase of growth because it is affecting the carrying capacity of the environment. Now we are talking about something else, which is the competition that is taking place between members of different species. So always this competition is given by the signs minus minus, so it's affecting the ability of both species to survive or to reproduce, and this is the situation that we will see when there is a limited supply of resources and both species are sharing the same niche, so there is an overlap in their niches. And to define the niche, we will say that it is the range of resources that can be used by a species, or it is the range of conditions that this species will tolerate. So as you can see here in this picture, we have lions and hyena, and they are both fighting because actually they are seeking the same prey. So here we have a situation of overlapping of the niches. So this competition will increase if the number of prey that both of them target is limited, so the competition will become much stronger. If we have a very strong competition, it may lead us to something we call competitive exclusion. So now the strong competitor is going to exclude the less strong competitor out of this niche, so it will lead to the elimination of the weaker or the less strong competitor. And as we said, this happens when there is a complete overlap between their niches and the environment or is of limited resources. It cannot withstand both competing species, so there is no way of coexisting together. So the situations of a competitive exclusion is a bit rare. Most of the cases we will find what we call coexistence, So coexistence, meaning that the two species will coexist together, and in order to exist together in environment with limited supply, what they will do, they will need to differentiate their niches. So niche differentiation will happen in order to allow this coexistence. So what will happen? The strong competitor will take its favorite resource, and it will force the less strong competitor to use another resource. This resource can be food, as we said. It could be space. So niche differentiation may involve resource partitioning based on food or space. One example that we can mention is about the warbler niches. So these three warblers are using the same niches. So in order to coexist, they will do resource partitioning, but in this case we are partitioning the space. So imagine like there is a partition here and there is a partition here, and this one will live at the top of the tree, this one will live at the middle of the tree and will feed from the part of the tree from the middle. This one will live and feed from the part of the tree at the base. So by resource partitioning, now we are allowing niche differentiation, which will allow coexistence. One neat example of coexistence is what we can see in the Galapagos finches. So sometimes this niche differentiation may lead to character displacement, and that's what we see in the Galapagos finches. So as you can see in this figure, we have two types. So two types of birds. If they live alone, so if this bird lives in one of the islands, this is the beak depth, and this is the other one has this beak depth, and as you can see there is a bit of overlap between the finch beak depth. So if they will live together, now there will be a competition. So what happens is character displacement. So in islands where the two birds live together, we find displacement. So this one, the beak depth will displace to this direction, and this one will displace to that direction. And this is a very neat and scientifically evident example that niche differentiation may lead to character displacement. So moving on, in addition to competition, we may have predation and herbivory. So this one is plus minus interaction. So one organism eats or kills or attacks the other, so it gains benefit, which is usually the food, and the other one is harmed by this interaction. So here we can see example of predation. When we move on to herbivory, it is more or less the same concept, but in this case the organism will eat parts of a plant or algae, so as exemplified by here. But both of them is plus minus interaction. So it's a plus for the predator, minus or a negative for the prey. So we have seen many examples in the nature about adaptations, both in the predator and in the prey, in order to establish this relationship. So the predator, to be more successful as a predator, they have adapted claws, teeth, fangs, stingers, and poisons. In terms of the prey, they have displayed various defense adaptations. It could be morphological things like spines or the release of toxins, or it could be behavior changes like hiding, fleeing, forming herds. So we have shown examples of the elephants, or it could be like fishes, so they make schools, or by self-defense or alarm calls. So all of these are examples of the adaptations that we will see under the interaction which is predation and herbivory.